Guys, let's get you now fully settled, and then we'll give you a sense of what we're up to today. We're going to dig in. You're going to see that we're going to be together for about 25 or 30 minutes, laying some groundwork for what you're going to be working on for the rest of the day. And then you guys are going to have a productive day and get some stuff done. Remember, this is our first early out Monday. Maybe we should talk. You guys know the schedule is different. So we go 1, 2, 3, 4 lunch, which functionally means if you don't want to eat lunch here, you're actually out earlier than you have been on previous Monday early outs, simply because a little different. So guys, the date today, holy smokes, 26th. So guys, the date today is the 26th. The topic for your notes today is represented on the board. I would encourage you to write that down. And guys, today is part 2 of the 2-part series. We'll talk a little bit about what we did last time in class, and then we'll dig into what we're going to do to finally fine-tune our ability to gather data well. There's one additional concept that you're going to learn today that you're going to be using for the rest of the year. We'll lay that before you, and then we'll give you a bunch of time to get good at this. So again, guys, the date's the 26th. Today what we're going to do is talk about representing accuracy, and we'll define that better in a minute, and you should have that and then your paper from last time. You guys all good? Okay, so guys, do this with me. Grab the paper that you got from last time. And you'll notice as you look at mine that I actually focused in on a particular part of this paper. But guys, that's not where we're going to start. We're going to get there in a second. But what I'd like to do before that is just get your experiences, your feedback. How did Thursday go? How so? Tell me more. Pretty good's a good start. Okay. Okay. So you didn't find taking measurements to be challenging. Was it weird just going into that lab space at first? It was actually interesting to see you guys walk into the lab and you guys all sort of puddled together like you weren't quite sure what to do. And then slowly over time, we sort of spread out and got a little more comfortable. And by the end of the day, guys, it seemed like you were getting comfortable working in there. What about in terms of making these measurements? Guys, allow your eye to scan down the page, reminding yourselves about the things that you were measuring because you identified the objects that you were measuring. Were any of them particularly difficult? Did any of them bring up questions? This is that awkward silence like a weird first date. Any of them particularly challenging? Which ones were the easy ones? Yeah, the digital ones are always the easy ones, right, you guys? And I know it's Monday morning and we're tired, but the digital ones are always the easy ones because you're just writing down numbers. So guys, maybe that might be a good segue into the question at the bottom. Did you notice that there's a question at the bottom of the page? Did y'all have the opportunity to answer that? It basically says, what is the trend? What is the pattern between the numbers that had circled digits and the numbers that didn't? So guys, what's the big idea? Those circles are critical, especially given what we're going to do today. So guys, what do those circles tell us? What do we know about the numbers inside those circles? They're always estimates. So guys, be really clear about this. And if you haven't answered that question, go ahead and do it with me right now. Guys, all of the numbers that are in circles are estimated digits. Remember, we never do that when we have a digital scale, but we always estimate when we're measuring against a numerical scale. And so all of the digits that are in circles are estimates, and therefore, we're not confident that they're right. Everything outside of the circles we are confident of, but the ones that are in the circles we're not. Guys, do you need more clarification on that last question? You guys okay? You're sure? Okay, so guys, what I'd like to do then is I'd like to focus in on numbers 8, 9, and 10 with you. Some of you called this thing a beaker. That's not right. It's a graduated cylinder. But guys, if you don't remember in 8, 9, and 10, what you did is this. You were actually given, let me see if I have one here. I don't have a plastic one. Oh yeah, I do. So guys, basically what happened in 8, 9, and 10 is you were given a plastic graduated cylinder, and then you were given this ridiculous meter stick that's broken into tens and hundreds and thousandths of a meter, and you were asked to make a measurement relative to the length of the graduated cylinder. Guys, you'll notice that I took the circles off my page. So guys, look at your page. Where were the circles? In 8, 9, and 10, where are the circles? Not what is the number in the circle, but where are the circles in those numbers? So they're in the quantitative column, but I mean relative to the numbers, where are the circles? They're always last, right? Guys, the idea is that the circles are always last. And the idea behind this is that when we're estimating digits, we are always estimating the last digit. So when we first made this measurement, we had a scale that was broken into tens. Therefore, we estimated to the ones. Then we had a scale that was broken into individual centimeters, the ones. So we estimated to the tenths. Then we had a scale that was broken into tenths, and we estimated to hundredths. So guys, let's pause for a second. What questions do you have about the stuff that you did in lab on Thursday? How we estimate, when we estimate, the measurements that we were making, and so on. Because I want you to get this thing right. And I'm getting the sense that there's some tentativeness that I'd love to answer questions if you got them. You guys really okay? You're good? We're okay? All right. So guys, if you're really feeling good about this, then let me ask you a question. So again, guys, in 8, 9, and 10, we measured the length of this graduated cylinder. We understand that the graduated cylinder is about 24 centimeters long. But guys, the question that I have for you is this. Which one of these four measurements, top, middle, or bottom, which one of these four measurements is best? Which one do you think is most likely the length of the graduated cylinder? And guys, I need thumbs. So grab your thumb, top, middle, or bottom. Which one of these measurements do you think is best? Seeing a lot of thumbs sideways, perhaps some thumbs down. Tell me about thumbs sideways. Why do you think the middle one is best? Okay. So if all of these measurements are in the range of 24, but you're suggesting that that middle one is the most correct. You're guessing. Other thoughts? Lots of votes for the bottom. Guys, why are we going bottom on this? We're gonna go to the back corner. So Sophie, why are you thinking bottom? Wow, you actually said that really well. Let me bring this back here. Guys, hopefully you can see this. Can you say that again for us? Because you're exactly right. Go ahead. Okay, and so the idea is this. If we were to measure with a ruler that's broken into tens, we are immediately estimating, right? We're estimating to the ones. If we have a scale that's broken into ones, we are then estimating to the tenths. But if we've got one that's broken into tenths, we can immediately estimate to the hundredths, which is probably more accurate because it's a better scale. Is that kind of the... Guys, does that make sense? Because that's an important concept. When we make measurements in this class, we are always going to try to make measurements in a way that makes them as accurate as we possibly can. And in order to do that, it means we need better measuring devices. But guys, whether our measuring devices are good or not, and this is where you need to grab your note sheet, grab it because we're going to start writing stuff down. Guys, regardless of how good your measurement device is, guys, the trick is this. When you're making these measurements, we've got to be making measurements and recording them in such a way that our accuracy that we're given is appropriate given the thing that we're measuring. So guys, the idea is this. Imagine if we made this measurement with this scale. So this is the scale that's denoted in tens, and we've got this. And imagine if we made this measurement and we said 24.0137 centimeters. Can we do that with this? No, because this scale isn't that accurate, and therefore our measurement can't be that accurate. So guys, what you're going to see when we make measurements here is our goal is to make our measurement appropriately accurate, but then it's also to record it appropriately. And that's what we're going to talk about today, is as we make these measurements, how can we record these measurements in appropriate ways? So guys, to do this, what I need to do is lay down some groundwork for you, and it goes like this, and you're going to want to scratch this in your notes. So guys, the idea is this. When we make measurements, as you did in lab, and from what you're telling me or not telling me, and guys, understand, we're going to get better at asking questions, but understand your silence tells me that you understand what we're doing. And if you're not a person that naturally asks questions, because let me encourage you to try. You're going to find that your questions are shared by other people. And so if you find yourself going, I'm not really sure, it doesn't even need to be a well-formed question. It can simply be, I'm not quite sure. But with that said, guys, all of these measurements that you made in lab, whether it was the temperature of the air, how long you could whistle, or whether it was the length of a graduated cylinder, guys, every single one of those measurements actually communicates three different things. The first thing that it communicates is the type of measurement that you took. Is it a length? Is it a weight? Is it a time? Is it a mass? Is it a temperature? Guys, first thing that we take out of measurements is the type of measurement that we took. By the way, guys, how do we know? By looking at a measurement, what about the measurement tells us? Go ahead, Spencer. Exactly. Guys, if you've ever wondered, why do we need to label our numbers? Why do we need to put units on our numbers? This is the answer. Because the units tell your reader what it is you're measuring. If you just write down 24 and don't label it centimeters, your reader does not know what you're measuring. So guys, the first thing a measurement always does is it tells us the type of measurement. The second thing it does is it tells us size. That's kind of straightforward. Is it big? Is it little? That's the number that you're recording. But then, guys, and this is the big nugget for today, the third thing that these measurements communicate is the accuracy of the measurement. And Sophie, you'll notice you actually brought that term up and used it very well in context. So guys, when we make measurements, we not only need to communicate what we're measuring, we not only need to communicate how big this thing is, but guys, we've also got to communicate the accuracy of the measurement. So if you're not clear on this, let me define it for you. Guys, accuracy simply means the correctness of the measurement. So when we talk about accuracy, we're simply talking about how correct is the measurement. So guys, keep these three things in mind. What do measurements tell you? They tell you what you're measuring, they tell you how big the thing is, and then they tell you how correct it is. So guys, I'm going to give you some examples of some measurements, and I want you to put them to this three-part test. What are you measuring? How big is it? And then finally, how accurate is it? So here we go. Don't write down the examples, but guys, we're going to think about it, and then I'm going to actually have you participate by voting. So guys, 60 miles an hour. Don't write them down, but put it to the three-part test. What are you measuring? How big is it? And how accurate is it? So guys, first of all, 60 miles an hour, what do you suppose we're measuring? Speed of a car. You can picture a car moving 60 miles an hour. So we know from the units that we are measuring the speed of probably a car. Now guys, question number 2 is this. How big is it? Is that a big speed or a small speed? Well, it's relative, right? If this is a car moving down I-15, it's probably appropriate. If this is a car in a school zone, we've got problems, right? So guys, many times size is relative. But then guys, what about this? What about accuracy? How accurate do you suppose this is? If you're in a car with this person and you go, hey, how fast are you going? They go 60. Do you think they're really going 60? It's probably just close, right? If somebody tells you 60 miles per hour, they may or may not be going 60. But what if they turn to you and they go, I'm going 58.2 miles an hour? Now you're thinking that's going to be more accurate because they're communicating more digits. So guys, again, we know what they're measuring, we know how big it is, and then we're thinking this probably isn't that accurate simply because that number doesn't represent a lot of accuracy. So guys, what about something like this? 1,225.75 pounds. First of all, what are they measuring? They're measuring the weight of something. Big or small? Huge, right? This has got to be something enormous. It weighs half a ton. So we're measuring weight, which is an amount of stuff. And guys, this thing has got to be relatively big. But what about the accuracy of this measurement? Give me thumbs. High accuracy or low accuracy? What do you think? We all going high? Why do you think this is an accurate measurement? Oh, sorry. Go ahead. No, you're good. Go ahead. It's got digits, right? It's got decimal places. This thing is 1,000 pounds big, but we measured its weight out to hundredths of a pound. So guys, do you see how this measurement is more accurate than this measurement because of those decimal places? That's going to be important in a second. You starting to get the idea? Let's try another one. So guys, 100,000 feet. First of all, what are we measuring? The length or the distance between two things. So guys, big or small? Big, right? We're measuring something relatively big, but now, Ammon, let's go. What about accuracy? Do you think this is an accurate measurement? Why not? Totally agree with you. Hey, how far away is Lehigh? 100,000 feet. Really? No. Maybe. Don't know. But guys, the idea here is when we throw out numbers like 100,000, yeah, it tells us that this is big, but it doesn't tell us about accuracy. And remember, guys, what we're doing today is talking about accuracy. And so what we're finding is some numbers look accurate and other numbers don't. So now let me give you another measurement. 0.0001 grams. What do you think you're measuring? Well, first of all, what are we measuring? Not weight, it's weight or mass. We'll use them interchangeably. So weight or mass. So guys, maybe we should do this quickly. How much mass is a gram? Do you remember from the activity? What weighed a gram over in lab? Paperclip and, very last one you did. What else weighed a gram? Milliliter of water. It should have been close. So guys, we are talking about a 10,000th of a paperclip. This is actually about the mass of a human hair. Pretty close. So, guys, talk to me about this number. We know that we're measuring mass. Is this thing big or small? Small. What about accuracy? Is that an accurate measurement? Let's go high or low accuracy. What do you think? High? Low? We got both. Why do you think it's highly accurate? Yeah. And so what I think I hear you saying is if it's something that small, it has to be accurate or you couldn't measure it in the first place, right? But guys, just a second, Spencer, let me offer you this. What about if we compared it to this measurement? Still 0.001, but now 975. Both of these are masses. both of these are small, but now which one is more accurate, top or bottom? Which one's more accurate, the top or the bottom? 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 Anyone thinking top? Diana, why the bottom one? Absolutely. Can we agree on that? Would you agree with that? So guys, this is the spirit of what we're trying to think through today, is this idea of communicating accuracy. So let's talk about the three. We understand that when we take measurements, the units tell us the type of measurement, the number tells us the size. But then guys, what we're finding out is in order to communicate accuracy, it has something to do with the specific digits. And guys, this is where we need to get our arms around an important idea. Because when we take measurements, we are very, very concerned about accuracy. So much so that we give a special name to digits that communicate accuracy. So guys, I wouldn't write all this down, but this is the deal, and this is what makes today tricky. Guys, the tricky bit about what we're going to do today is we need to figure out how to deal with zeros. Because guys, if you look at these numbers, we said that that's really accurate because it's got a lot of digits. This is really accurate because it's got a lot of digits. But when we run into these zeros, things get weird because we're not sure if zeros tell us about accuracy. So guys, what we're going to do is we are going to fix all these zeros, all these issues with zeros by talking about what are called significant digits. So guys, next thing in your notes needs to then be this. What are significant digits? Guys, write this down with me, and then we're going to start to apply this. So guys, the question that we're asking is this. How do we know how accurate a measurement is? And the answer is, how many significant digits does it have? Because guys, significant digits are numbers that communicate accuracy. Now guys, here's the deal. You are about to get 4 rules for identifying significant digits. Now guys, here's the trick. You will never have to regurgitate these rules. I will never ask you to throw up these rules on a test and go, what are the 4 rules for significant digits? You'll never need to do that. All you've got to be able to do is apply this, and you're going to be doing it for the rest of the year. So don't memorize the rules, understand the rules, and then guys, for the remainder of the day, we're just going to play with the rules. So guys, it goes like this. And this is kind of what Diana was getting at just a second ago. So guys, rule number 1 is this. Any number that is not a 0 communicates accuracy. Any number that is not a 0 communicates accuracy. And what you've got to be able to do with this is you've got to be able to count significant digits. So write down don't write down the examples, just play along. So guys, if we have a measurement that is 96 grams, don't write it down. If we have a measurement that is 96 grams, how many significant digits? 2. The 9 and the 6, because neither one of those is zeros, therefore that would be 2 significant digits. So if you were asked how many significant digits in 96, you just got to go 2. So let's try another one. Guys, what about 61.4 meters? Show me fingers. How many significant digits? Are we all okay on 3? You're good on 3? All 3. What about the decimal place? Doesn't matter. 3 significant digits. So guys, let's try one more. What about 0.52? How many significant digits? 2 or 3? Because here's the problem. We don't know. Because we don't have any rules about zeros. You're going to find out the answer is actually 2. The 0 is just a placeholder. But guys, the idea is that the first rule tells us that all digits 1 through 9 are significant. The question becomes, what about the zeros? So guys, guess what the next 3 rules are about? The zeros. So guys, it goes like this. Rule number 2. Final zeros after the decimal place are significant. Final zeros after the decimal place are significant. So guys, maybe we should talk about this really quickly. Let me define this for you more clearly before we dig into this. So guys, what does it mean to be final? That means at the end. So when we say final, we mean zeros that are at the end. When we say after the decimal place, we mean to the right of the decimal place. So guys, for zeros to be significant, they've got to be at the end of the number, and they've got to be on the right-hand side of the decimal place. So let me give you some examples of this. So guys, for example, consider this number, 10 centimeters. How many significant digits in 10 centimeters? Is it 1 or is it 2? Guys, it's actually just 1, and here's why. This 0 is final. It is at the end of the number, but it's not after the decimal place, so it doesn't count. So let's look at this. What about 10.0? Now let's take a look. So guys, that 0 is that, let's do it this way. So we know the 1 is significant. What about the 0? Is that 0 significant? It is, because it's a final 0 after the decimal. Final means at the end of the number. After the decimal means to the right of that. Does that make sense? Okay, so guys, let's do one more example. Oh, actually, hold on. We'll come back to it. So guys, when we look at 10.0 then, zooming out. So guys, when we look at 10.0 then, we've got the idea that the 1 is significant because it's not a 0, and then that 0 is significant because it's a final 0 after the decimal. It tells us we looked for 10s and didn't find any. So guys, here's the question. What about that 0? What about the middle 0? Is it significant? We need another rule. And guys, the other rule is rule number 3. And it talks about that 0. And guys, rule number 3 is this. Trapped zeros are significant. So guys, when we say trapped, we mean stuck between two other significant digits. So when we take a look at this, again, we've got 10.0. So guys, let's talk about this to make sure that you're clear. And then we're going to talk about the fourth 0, and then you're going to have the opportunity to play with this a little bit. So guys, is the 1 significant? Yes or no? Yeah, how do you know? Because it's not a 0. So guys, what about this 0 over here on the right? Is that guy significant? It is. How do you know? Final 0 after the decimal. So now guys, what about the 0 in the middle? Is it significant? It is, because of rule number 3, because it's trapped. The 1 is significant, the final 0 is significant. This guy is trapped, so that would be 3 significant digits. Does that sit okay? Okay, so guys, let's look at one more example, then the fourth rule, and then we're going to play with this a little bit. So guys, it goes like this. What about this guy? You do well. How many significant digits in that number? Is it 1? Is it 3? Is it all 6? 1, 3, or 6? Show me fingers. Now we got 2 hands. Are we in agreement on that? So the 8 and the 3 and the 5 are significant. Guys, what about all those zeros? Yeah, they're all trapped. So you can trap strings of zeros. And if you think about it, guys, it makes sense because these zeros are telling us that Lee looked for tens, hundreds, and thousands and didn't find anything. But that tells us about accuracy, and that's what significant digits do. You feeling okay? Let's do one more. Guys, rule number 4. Rule number 4 simply says nothing else counts. That's it. Guys, nothing else counts. There are no other significant digits. So non-zeros are significant. Final zeros after the decimal place are significant. Trap zeros are significant. Nothing else communicates accuracy. What do you think? You okay? Guys, let's do this then. Do they still do family home evening in Utah? I thought it went away. All right, so if you're looking for something to do for family home evening tonight, let me offer you this as hours of fun for the whole family. You gather everybody around the computer, mom, dad, brothers and sisters. The link is right here. You click on the link. This is the significant figure game of science. Huh? What could be more fun than this? Here's how this works. So you follow that link, you go to this page, you click on new number. Oh my gosh, 0.18. How many significant digits? We got 2, we got 3. Give me fingers. We got some votes for 3. We've got some votes for 2. So guys, let's go through the logic. The 1 and the 8, are they significant? Do they communicate accuracy? Absolutely, because they're not zeros. So now let's talk about the zeros. Is that 0 a final 0 after the decimal? Is it after the decimal? Absolutely, but is it final? It's not. It's not at the end of the number. Guys, and so is that 0 trapped? No, there's nothing to trap it. So guys, that 0 is not significant. What that 0 is doing is talking about size. Remember, we've got 3 things, right? What we're measuring, the size of what we're measuring, and then we've got the accuracy of what we're measuring. And guys, all that 0 is doing is making the number smaller. It's not making it more accurate. So this would actually be 2 significant digits. Ready? Check your answer. Oh. Correct. Okay, it's not that fun. All right. So guys, what about that? How many significant digits? 7? I can't even count them. So we know the 3 and the 4 and the 5 are significant. Guys, what about that 0 and that 0? Are they significant? How do you know? Because they're trapped, right? Now we got to deal with the last zeros. Are those final zeros after the decimal? Absolutely. They're final because they're at the end of the number. They are after the decimal, so they count too. So we've got 1, 2, 3, 4, 5, 6, 7. So 7 significant digits. Check your answer. We are now 2 for 2. So let's look. What about those zeros? Significant? Yeah, final zeros after the decimal. What about that? All significant. Zeros are trapped. What about, these are boring. What about that? Significant, that 0? Yep, final 0 after. What about that? Are those zeros significant? They are not. They are simply making the number smaller. They are not final zeros after the decimal. They don't count. What about that one? Final 0 after the decimal. Now guys, let's talk about this. Are you guys familiar with scientific notation? This is a number in scientific notation. Functionally, what this is saying is this. So it goes, so when you see something like this, what it's saying is 2.04 times 10 to the negative first. Guys, in order to figure out significant digits in a number like this, all you got to do is look right there. Is that 0 significant? That's all you got to do. It is significant. It's trapped between the 2 and the 4. So guys, when you're doing significant digits for numbers in scientific notation, all you got to do is look at the root of the number. You guys okay? We're doing all right? Okay. So guys, one more thing we need to talk about, and then you're going to get some work done. So it goes like this. And these you're going to want to write down with me. So guys, while it is important to be able to identify significant digits, it doesn't stop there. So guys, write these 3 numbers down big and across your paper so that eventually they're evenly spaced and take up the whole page. Because guys, while it is important to be able to identify significant digits, you also need to be able to round to significant digits. So I'm going to show you a few examples of this. And then, guys, we are going to wrap up that activity page that you started. And then once you're done with that activity page, you'll see what we're going to do next. So you guys okay? Are you all caught up with me? Okay, so do this. Guys, in each of these numbers, ignore the stuff that says 4 and 2 and 2. Ignore those. And here's what I want you to do. Above these three numbers, write down the number of significant digits in each one of them. Remember that when you're doing that, what you're actually writing down is a measure of how accurate they are. How accurate is 314.721? How accurate is 0.001775? How accurate is 8,092? Write down the number of significant digits. So guys, let's take a peek at those, and then we'll talk about how to round these numbers. So guys, number on the left, can we agree that that's 6 significant digits because there ain't any zeros? Is that okay? Okay, so that one's 6, and I'll write it down just so we can remember. Then guys, the middle number, we know the 1, the 7, and the 5 are significant. What about those zeros? None of them are significant. Guys, this would actually be 4 significant digits. The 1, the 7, and the 5 are significant. These zeros are after the decimal, but they are not final zeros. They're not at the end of the number, and therefore they don't count, so that would be 4. Now guys, what about the last one? Is it 3 or is it 4? Do you see why it's 4? What about that 0? That dude's trapped. Good for you. All right. So guys, this would then be 4 significant digits. You guys feeling good on that? Okay, so this is the last skill that you need to pick up today, and then you're going to have time to work on some stuff. So guys, what we're going to do now is we are going to round these numbers to the number of significant digits that are given in the parentheses. Guys, this is the way to do it. I would encourage you to do this with me. Here we go. So guys, we're going to take this number on the left, and we are going to round it to 4 significant digits. So what I like to do is this, and you're welcome to do this with me, because I'm going to put dots above the 4 significant digits. That helps me visualize what I'm doing. So I'm going to round this number to 4 significant digits. So that means I need the 3, the 1, the 4, and the 7. Then, just like the quiz that we took at the beginning of the year, because we got to look at this 2. And the 2 tells us to round up or round down. We're going to round down. But now, guys, the question is this. If that rounds down, we end up with this. But now the question is, what do we do with the 2 and the 1? Do we replace it with zeros, or do we cut them off? And you may remember the very first day of class we said, if we're rounding below the decimal place, we cut them off. We don't replace them with zeros, so this would be that number rounded to 4 significant digits. Now guys, if you're sitting there right now going, wait a minute, why don't we replace these with zeros? Guys, don't do this, but watch. If I do replace the 2 and the 1 with zeros, how many significant digits do I have now? Back to 6. Because those are final zeros after the decimal, and that is why we don't replace them, because if we did, we would just be putting back significant digits we wanted to get rid of. Does that make sense? Questions? You okay? Okay, so let's try the next one. Guys, we're going to take this number and we're going to round them to 2 significant digits. So let me give you a little less support. Guys, put dots above the 2 significant digits that you're going to round to. So we identified that the zeros are not significant, so we're going to do the 1 and we're going to do the 7. So we're going to round to there. So then, guys, we look at the next digit, and the next digit is a 7, which tells us to round up. So we are going to go 0.0018, rounding up, and then we chop off the 7 and the 5 because we're below the decimal place, and therefore we don't replace. Does that sit okay? Feels good? Okay, so guys, one more. Again, place the dots above the digits that you're going to round to. We're rounding this to 2 significant digits. So guys, place the dots. Then do the rounding. Come up with an answer. Do it on your own. And then we'll take a look at where we're at. Be okay? All right, so guys, here we go. We're rounding to 2 significant digits, so we've got 1, we've got 2. So then we look at the next digit, which is a 9. That tells us to round up. So what are we going to write down? 81. So the 0 rounds up, so this is 81. Now guys, what do we do with the 9 and the 2? Do we replace those with zeros? Now we do. And guys, if you're not sure why, check this out. If we don't replace the 9 and the 2 with zeros, we took 8,000 and turned it into 81. We radically changed the value of the number, and that's not rounding. So we do replace this with zeros. But now you're thinking, wait a second, if we replace it with zeros, doesn't that mess things up? Guys, how many significant digits in 8,100? And so we did it. Do you get the idea? So guys, what questions do you have about the practice of identifying significant digits and rounding to the requested number of significant digits? You guys okay? You sure? Okay, so guys, do this. Grab the activity sheet that you have from last time. Goes like this. So guys, if you grab this activity sheet, and actually let me grab the full copy of it. I don't want to look at this one anymore. So guys, what you're going to do is grab this activity sheet. And as you look at it, what you're going to see right here. Guys, you'll notice that there are 2 columns that you have not done yet. One says significant figures, and then the other says round to 1 fewer significant figure, significant digit. So guys, what you're going to do is you're going to take the number that's right in this space. So Colton, give me your measurement. Tell me what you have right here. Hold on a second. Let me get my writing utensils. So I'm going to do the first one with you to make sure you know what you're doing. So tell me what you got right here. Is that the temperature of something? Yeah. What is it, is it the water or the air? Okay, so give me your temperature of water. What did you get? 22.0 Celsius. So guys, let me show you what this is going to look like, and I'm using Colton's data. Yours might be different, but here we go. So guys, 22.0 Celsius. How many significant digits is that? It's 3. So given his data, I'm going to write down 3. If your number is different, you'll write down however many significant digits there are in your number. Then guys, the next thing says, round this measurement to 1 less significant figure and then include units. And remember that this is degrees Celsius. So guys, what it's saying is if you've got 3 significant figures, round that to 2. So we go 1 and 2 significant digits. That 0 is less than 5, so it rounds down. So rounded to 1 fewer significant digit, this would simply be 22 degrees Celsius. And you're going to go through and do that for all of your measurements. Guys, interestingly, as you're doing this, and we'll talk more about this later, but if you're catching this and if you find this interesting, this idea of accuracy, guys, let me encourage you to do this. As you're doing your rounding, keep your eye on what happens to the numbers that you circled in your original measurements. As you're rounding to 1 fewer significant digit, keep your eye on those numbers that you circled. Something happens to them all the time. It's kind of interesting. So, guys, do you need more guidance on what we're doing with this activity? You guys okay? Okay. So, guys, it is early out. We are done at 8:55, which gives you 25 minutes. Now, guys, here's the trick. This is not the only thing that we are doing today. So the way today is going to go is this. You are going to finish doing your rounding for all of these numbers. This is going to be ugly. Oh, good. So guys, you are going to finish that up, and then I will trade you that activity for a homework assignment. Guys, this is due on Wednesday. You may be able to get all of this done right now. But guys, let me show you how this homework assignment works so there's no confusion. And so what will happen is when you're done with this activity, you will come up then and you will trade me for a homework assignment, and this will then be due on Wednesday. So guys, this is actually what the homework assignment looks like. And so, and I'll leave this up on the screen just so you can see it. But here's how this homework assignment works. On the top, it is simply asking you to identify the number of significant digits. So do this with me. Guys, 71, how many significant digits? 2. So you're going to write it down. And you're going to do that for all of them. Then when you get down here to this part, it says rewrite the numbers above with the requested number of significant digits. So for example, this is referencing this, and they just moved together. And so this is saying take 71 and round it to one significant digit. So 7 is the first significant digit. The 1 rounds down, and that would be 70. So how many significant digits at the top? Round them at the bottom, and then you'll see on the back there are a couple questions for you to answer. So guys, you're welcome to work with the person that you're seated with. And your numbers may be different, but you're welcome to work in partners if you'd like. Finish up this activity. When you're done, bring it to me. I'll look it over, answer any questions that you might have. Then I'll trade you for your homework, and then the rest of the day you can spend getting this homework done. If you get the homework done, you're done for the day. Otherwise, finish.